Hello everyone. Today we're going to discuss about one of the common experiments that we're going to do in chemistry. It's called gravimetric analysis of chloride salt. I'm going to write the topic. It's called gravimetric analysis of chloride salt. Chloride ion. Okay. So first of all, to make it clear, this is one part of quantitative analysis. Remember, in chemistry, two main experiments that we do is quantitative versus qualitative analysis. So a quantitative analysis is always concerned with amounts, its measurements. In other words, it is like quantities, percentage or mass, volume. This is called quantitative, and qualitative is focused on identification of substances. So in that regard, the gravimetric analysis is also a part of quantitative analysis. So gravimetric, it derives its name from the fact that the constituent being determined would be isolated in some weightable form. We also have something called volumetric analysis. The amount of the constituent involves the measuring of the volume of the reagent. So our goal today is discussing about how we can able to determine the amount of chloride salt by using some kind of reagent called silver nitrate. Okay, so first of all, let's say that you have an amount of certain amount of potassium chloride. When potassium chloride react with let's say silver nitrate, silver nitrate is used as an aqueous solution here. We get silver chloride, which is insoluble substance, so I put S, and potassium nitrate, which is soluble, and I put AQ. Whenever you have soluble in water, we put that AQ. And so when we do the potassium chloride here is also aqueous. When we do the ionic equation for this, we're going to have a potassium ion and a chloride ion, and the silver nitrate, since it is aqueous, it's also be decomposed into a silver ion and a nitrate ion. Okay, and on the product side, you have silver chloride. It's not going to be decomposed. It is a precipitate, so we'll leave it as is. It's going to be AgCl plus potassium nitrate. It's aqueous, so we will have a potassium and a nitrate ion. So what we have here, we have a ionic equation. Ionic equation means it's something that when you write the metathesis reaction or the molecular equation in form of ions. Now we need to identify the spectator ions. What it means is that spectator ions means the one you have on the reactant side, and at the same time you have on the product side. We're going to eliminate those ions. So we have potassium ion, and we have from this we're going to remove the spectator ions, like I say, potassium on the reactant side and potassium on the product side. We also have nitrate on the reactant side and nitrate on the product side, and what we have here is called a net ionic equation. A net ionic equation, which means you have silver on the reactant side and chloride also on the reactant side. On the product side, we have silver chloride. Okay, now this is called an Newtonian equation. This equation is very important for so many reasons. It first illustrates the concept of stoichiometry. Stoichiometry is basically the proportion in which the chemical elements combine, and the mass reaction in any chemical reactions would have to be balanced. In other words, whatever amount that you have on the reactant side, you need to have the same amount on the product side. So the idea here is that we're going to compare the amount of chlorine versus with the amount of silver chloride. Okay, so here we can see that for every 1 mole of chloride ion, you will get 1 mole of silver chloride. Okay, remember, stoichiometric and gravimetric analysis is analysis by using the amount of silver chloride. We're going to determine, or we're going to calculate the amount of chloride ion in the sample, in the unknown sample. So in this experiment, what it means is that the mole ratio of the substance between chloride ion and silver chloride are the same. So what basically means that 1 mole of chloride ion reacts with 1 mole of silver ion to produce 1 mole of silver chloride. Now, what is a mole? Just a definition of mole. A mole means, like, you'll have a given mass divided by a molar mass. That's how a mole will be calculated. So so the mole of chlorine is basically the same as a mass of chlorine, or mass of chloride ion, divided by the atomic weight of chlorine. Okay, and the mole of silver chloride would be grams of silver chloride divided by the molar mass of silver chloride. So basically, like I say, in this experiment, the silver chloride is the insoluble part. It can be collected on a filter paper. You will have a filter paper. It will be collected there. It's insoluble. It has to be dried for some time. At least it might need 24 hours to be completely dried, and then has to be weighted. It has to be weighted. So that way you'll get the mass of silver chloride. From the mass of silver chloride, we're going to determine the mass of chloride ion. Okay, the mass of chloride ion, which is our unknown. Okay, so how do we do that? Like I said earlier, the moles of chloride ion is equals to the moles of silver chloride. All right, so what does that mean? Now, moles of chloride ion would be the mass of chloride ion divided by the weight of chloride ion. The weight of chloride ion, if you look on the periodic table, is going to be 35.5 grams. The moles of silver chloride again would be the mass of silver chloride, and this mass actually comes from the precipitation, from the insoluble particle, the one that is dried and weighted, and divided by the molar mass of silver chloride. The molar mass of silver chloride is going to be the mass of silver and mass of chlorine has to be added together. The mass of silver is going to be 107. I'm just telling you at the top of my head, but I can just give you the information from the periodic table. The atomic weight of silver is, yes, 107. It's almost 108. Okay, let's do 108. And the mass of chloride is 35.5. So silver would be 108, and chlorine is 35.5. And when we add 108 and 35.5, we would get about 143. Yes, 143.5. If you have your calculator, you can add that. That's going to be the mass, the molar mass of silver chloride. Okay, so that's going to be 143.50 grams of silver chloride. Now we're interested with the mass of chlorine. So the mass of chlorine from this value is going to be, when we do crisscross here, when you do the multiplication to get the mass of chlorine, 35.5 gram divided by 143.50 times the mass of silver chloride. So if you divide 35.5 by 143.5, you may get about 0.2473 if you round it up to that number. Okay, about that number, and times mass of silver chloride. Okay, so this number 0.2473 is called the gravimetric factor. This number is called what? A gravimetric factor. I'm going to write this down for you. Gravimetric factor. This is like, it's a very important number. It's a constant number. A gravimetric factor is a constant number that will help you to change the mass of a known silver chloride into a chloride ion. So remember, you'll be interested to calculate mass of chloride ion. So mass of chloride ion from the unknown sample can be obtained by multiplying 0.2473 by the mass of the dried precipitate weight of silver chloride. Okay, that's how we can calculate that. So I'm going to provide you a kind of calculation that will help us how to convert the weighted precipitated mass of silver chloride into the mass of chlorine, and we can do some kind of additional calculations as well. So we know how to calculate the mass of chloride ion from silver chloride, and the other thing is that we were interested to find out how much is the percentage of chloride in a sample. The percentage of chloride in a sample again can be calculated as the mass of chloride in a sample, in the original sample, I would say, in the original sample, divided by the mass of the sample. When I say sample, I'm talking about the original sample, so times 100%. So that's how percent of chloride is calculated. So now what I'm trying to do is we're going to do some calculation. The calculation that we're going to do a gravimetric analysis. It's a gravimetric analysis of chloride ion. And let's say that I'm going to give you a hypothetical number, gravimetric analysis of chloride ion. So we have an unknown. The unknown would be about 0.4579 grams of unknown of sample. I would say unknown of chloride sample. Okay, was obtained. Or let me put it in a different way. Maybe like if you have a gravimetric chloride analysis, there was about 4.579 grams of silver chloride was obtained. Okay, let me take this off. 4.579 of silver chloride was obtained. make it clear. Okay, this is after you did the precipitation, after you dried and waited. Okay, that was obtained from an unknown sample of chloride that has a mass of let's say 0.2543 grams of sample. Okay, now in this case, the question, there are two questions. I want you to calculate the mass of chloride ion in a sample. The mass of chloride ion in a sample. That's one question. The second question would be like, what is the percent of chloride ion in the sample? What is the percent of chloride ion in the sample? So the mass of chloride ion in a sample, basically the way how we calculate, like I say, is mass of chloride ion can be calculated as multiplying 0.2473, which is a gravimetric factor, times the mass of silver chloride. So we're going to multiply 0.2473 by 0.4579. Can we multiply 0.2473 by 0.4579? That's the mass of silver chloride. 0.2473 multiplied by 0.4579. So if you do the calculation, you may get about 0.1132 gram. I just write to 4 significant figure. Okay, so that's one thing. The next thing is the percent of chloride ion. The percent of chloride ion is going to be the mass of chloride ion divided by the original sample times 100. So that means the mass of chloride ion, which we calculated was 0.1132 gram, over the original sample that we had was 0.2543 mass of the original sample times 100. So that basically gives you, if you multiply 0.1132 gram divided by, that's the mass of chlorine, okay, mass of chloride ion, over 0.2543 gram, that is the mass of the original sample, okay, the original sample, times 100%, and it will give you about 44.5%. 44.5%. That is the percentage of chloride ion. In a sample. So this is how we do the calculation of the gravimetric analysis of chloride salt. So in summary, there are certain guidelines that I want you to use for the gravimetric analysis. Guidelines for gravimetric analysis is that first we have to drying, and we need to accurately weight the representative samples of the matter that should be analyzed. Second, we have to use dissolving the samples. The samples have to be dissolved. This is the experimental procedures. Third, it has to be precipitated in the constituent in the form of substance by adding a suitable reagent. So precipitation can be done by adding silver nitrate solution. That's our reagent. That's our reagent. This has to be added to the unknown mass of chloride. Okay, it can be potassium chloride, or it can be sodium chloride, or it can be anything, but it's a unknown sample. But this is our reagent, AgNO3 is our reagent to get silver chloride, which is our precipitate. Okay, and then whatever precipitate you get, you have to isolate the precipitates. This isolating by using filtration. So in this case, you need to have a filter paper. Filter paper is necessary to do this experiment. And then weighting the precipitate and make sure that the precipitate has to be free of any of contaminants. And then we have to dry the precipitate. I already said that in the first process. I actually have to say it here. Drying comes here, not in the first process. Dissolving the sample has to be the first one. So we're going to put drying here. Okay. And finally, we're going to calculate the percentage. Well, calculate actually the amount of chloride first. Calculate the amount of chloride ion in the sample by using a gravimetric factor, which is 0.2473 times the mass of silver chloride. That's this number never been changed. This is called a gravimetric factor. I use GF, gravimetric factor. So that's and then once we get that, the last thing is the percentage of chloride ion would be the mass of chloride ion divided by the original mass times 100%. That's how gravimetric analysis can be done. So dissolving the sample, form a precipitation by using a suitable reagent to get silver chloride, filter the silver chloride, the precipitate, by using appropriate filter paper, dry it, give it about like a day or two, or sometimes it might take even shorter than that if you use a furnace. It depends on how much time that you have, and the amount has to be weighted accurately, and subtract the weight of the filter paper to get the pure mass of silver chloride. And whatever amount that you get, multiply that by 0.2473. What is that number? That number is a constant number. It's called a gravimetric factor. That the mass of silver chloride multiplied by 0.2473 provides you the mass of chlorine. So you get the mass of chlorine divided by the original sample, which you started with, multiplied by 100, and it tells you the percentage amount of chloride ion. So this is how gravimetric analysis is being done. So thank you very much for watching this video. If you have any questions, please post your questions or contact me. I'll be happy to answer your questions. And if you really think that this video is very helpful, please share that with your friends. Thank you very much, and I'll see you with some other more videos. Thank you.